All right, ladies and gentlemen, part 2, dealing with cubic root functions. Now, when we type this in, ladies and gentlemen, we're not going to use the root symbol. Okay, I want you to rewrite that as the following. Okay, that's going to be x to the 1/3 power. Okay, think back to an earlier lesson on that, ladies and gentlemen. So when we go to the calculator, we're going to go ahead and put in x. Now, those of you with an old calculator, you're going to have to use parentheses around your exponent. But with the newer one, we don't need to. So hit your exponent button and then type in the 1/3. All right, so that's x to the 1/3 power. Let's go ahead and look at the graph. Interesting. Okay. Let's go ahead and see what type of points we can plot. So let's see here. Let's go into the negatives a little further. All right, let's go ahead. Oh, that looks like a good one. -8, -2. Okay, and it also looks like -1, -1, 0, 0, 1, 1. And again, I'm just picking out the ones that can graph easily. 8, 2. All right, let me write those down, folks. So we had, what was it again? -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. All right, let's plot those. So -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. All right, and it kind of looks like that, folks. And we do put an arrow on both ends. We do put an arrow on both ends. All right, well, the domain looks like everything, doesn't it? The domain is all real numbers. Okay, now for that, if you remember from an earlier video, I just use a big R. Okay, the domain is all real numbers. Looks like the ranges too, all the positive and negatives worked. So the range, I'm just going to do the same thing. The range is all real numbers. All right, this is our parent function. So now we're going to go ahead and do a couple more and see what's going on. Okay, well, actually, we got a whole bunch of different ones here. So let's see. This one, we've got 2 times the square root of 3. All right, well, let's just go ahead and take a look at it, folks. So we're going to go 2, and then we're going to go x to the 1/3 power. And let's look at the graph. Oh, look at that. Okay, it looks like it's gotten stretched, doesn't it? Okay, it looks like it's gotten stretched. If you want to graph it, again, go to the table and look for some dots that will fit. Looks like 8, 4 would fit. 1, 2 would fit, 0, 0, -1, -2, and then -8, 4, -4 would also fit. Okay, so what did that 2 do in front? Okay, this is just like the square roots in the last video, folks. Okay, this is going to be a vertical stretch. The domain and range are all real numbers. Okay, the domain and range are all real numbers. So the domain and range on this, ladies and gentlemen, is going to be all real numbers because all the numbers work. It doesn't matter what we do. The only difference is what will the graph look like. Okay, all right, so I'm just going to go ahead and do the rest of these, folks. This one here has a +5 inside. Okay, that means that one's going to translate left, not right, left 5 units. The domain and range will be all real numbers. The 1/2 cubic roots of x, that's going to be a vertical compression. It's going to get squished down. Okay, this one, ladies and gentlemen, this one is going to translate right. because the minus 8 does the opposite. It's going to translate right 7 units. If you don't believe me, type it in your calculator and take a look at it. This one with the negative in front, that one's going to reflect over the x-axis. This one with the plus 4, notice that it's not on the inside, it's on the outside. That one's going to translate up 4 units. Okay, if you don't believe me, type it in and look at it. It's going to go up 4 units compared to the parent function. All right. Again, use the power of pause and rewind if you need to. Okay, just one more thing I want to look at. I'm kind of getting ahead here a little bit, ladies and gentlemen. We're not actually going to use the calculator to model this. Okay, we're actually going to solve this directly. And again, I'm getting a little bit ahead. You're going to do more of this in chapter 6.6 in the next section, but it's a good idea to do this now. So let's take a look. We've got biologists who have found that the shoulder height h in centimeters of a male African elephant can be modeled by that equation, where t is the elephant's age in years. Estimate the age of an elephant whose shoulder height is 200 centimeters. Okay, folks, so what we're going to do is we're going to take this 62.5 cubic roots of t plus 75.8 and set it equal to 200. All right, here we go. So we're going to take the 62. Let me get my pen working here. 62.5 cubic roots of t plus 75.8, and we're going to set that equal to 200. Now, we're not going to work with the root symbol, so I'm going to rewrite that as 62.5 times t to the 1/3 power plus 75.8 equals 200. All right, we're going to solve for t, ladies and gentlemen. Here we go. We're going to subtract the 75.8. All right, let's see. 200 minus 75.8, and it looks like we get 124.2. And we've got the 62.5 times t to the 1/3 power. All right, now we're going to divide by the 62.5. And yes, it's okay to have decimals, ladies and gentlemen. So now we've got t to the 1/3 power equals, let's see, 124.2 divided by 62.5 is 1.9872. All right, now this is probably what's new, ladies and gentlemen. We've got a rational exponent there. And remember, what we do to one side, we do to the other. I want to get rid of that 1/3. So what I'm going to do is I'm going to take the reciprocal and multiply the reciprocal exponent to the 1/3. But when I do it on that side, I need to do it on the right side. Now, technically, the 1 is not necessary. So when I multiply the 1/3 and the 3/1, that becomes a 1, right? So all we're left with is t equals. Okay, ladies and gentlemen, now if I take the 1.9872, okay, 1.9872, whoops, 2, to the 3rd power, I don't need to put a 1 underneath it. You certainly can if you want, okay, but that over 1 is not necessary. You end up with 7.85. So this elephant is about 7.85 years old. We're going to do a lot more solving in chapter 6.6. All right? All right, ladies and gentlemen, good luck. We'll see you soon.